Hi everyone. Hopefully you've had a chance to have a look and try your hand at this exercise. I'm now going to go through the answer for you, so you can see how we're going to include this new concept of immunisation in the model. So I'm going to start off with the disease model file. First thing we need to do in the person agent class is we're going to need to pass in two new things into the constructor. Something called I've called the mean immunisation duration and probability of being immunised. And I'm going to store, these things are obviously going to come through from the user interface via the model to the agent. So the mean immunisation durations can be stored in the agent here, self.mean immunisation duration equals mean immunisation duration, the one that I've passed in. And the probability of being immunised we store down here. One other thing we're going to need to do is so the current immunisation duration I've stored as being 0 because they're not currently immunised. None of the agents are immunised. And I've also set up a parameter value here called immunised within the agent, which indicates that by default the agent is not immunised, because we didn't want anybody immunised at the start. So we've got self.immunised is false, and that will obviously change to true. They do become immunised. So that's what we're going to change in the constructor. Nothing's actually going to change in the movement function. It's not going to change how people move. In the infection function, things are going to change a little bit because we can't obviously now infect people who are immunised. So as before, we run everything as we did. We check how many cellmates we've got. If there's more than one cellmate, then we go through each cellmate and basically try and infect them. But I've added an extra condition here that said before we just checked if they weren't already infected, but I've also added "and" here to check if they are immunised or not, to make sure that they're not immunised. They need to be both not already infected and not immunised in order to be potentially infected. So we've added that in into the condition here. Nothing else about the infect function will change though. We have now here though got a brand new function which I've called become immunised. And this is a function that will immunise an agent. So the first thing we need to do in this function is to set to flag up that this agent is now immunised. So if they become immunised, they are now immunised. So we set up this parameter value called immunised in the agent. So we now set self.immunise equals true to now flag that they are immunised. But of course the immunisation only lasts for so long, so we then need to randomly sample from our exponential distribution how long that immunisation is going to last and set that to the immunisation duration. So in the same way we did for infection, we're now going to do the same for immunisation here. So self.immunisation duration equals, and then we're going to randomly sample that. Remember, we are casting as an integer here because we could only have full days in our time steps in the model. So that's our brand new function. Within the step function, we also need to add in a little bit. So we need to check to see whether the agent is currently immunised, and if they are, we need to decrement their immunisation duration by a day, and then see if they are no longer immunised, and if that's the case, then change their immunised status to false. If they're not already immunised, we also need to check to see randomly sample whether they are going to become immunised today. So the first thing we do, if self.immunised is true, so if they are immunised, reduce the remaining immunisation duration by 1 day. Then check to see if that amount means that they're no longer immunised. So if that now is less than or equal to 0, then we're going to switch the immunised parameter back to false. If they're not, if they weren't already immunised at the start of this time step, at the start of this check, then we're going to take a random sample to see whether they should be immunised. And remember, we've got a probability of being immunised as a user settable parameter. The default's to 5%. So we're going to use our standard method of sampling from the uniform distribution, checking if that's less than this probability. And if it is, then we're going to immunise them. So the way we do that is just by calling our new become immunised function up here. And that will then set their immunisation to true and randomly sample how long they'll remain immunised. So that's everything for the agent class. We'll come back to the disease model class in a moment because I'm just going to skip ahead. Remember, we also want to collect the number of people who are immunised over time. So in the same way that we had to create a function called calculate number infected, we also need to create a function called calculate number immunised so that we can calculate total number immunised over time. So I've written that down at the bottom, and I called my function calculate number immunised. And this is almost identical to what we had before. We've got a counter that starts here at 0, and then we use list comprehension to then go through and grab, in this case, the immunised status of each agent in the model. So again, we're still getting a list of trues and falses. And then for each one in that list that says true, i.e. that they are immunised, we'll increment our counter by 1 and then return that total counter after we've looped through everybody. That will give us the total number of immunised at that particular time step. So once we've written that function, within the disease model class, we can then call on this. So you'll see in the data collector, where we set up the data collector, we could add in another model reporter. So where we had total infected as being a label with the calculate number of infected function driving that, we're also going to add in the total I've called it total im label, and that's taken from the calculate number immunised function that we've just written. So we need to add that to our model reporters. Also within our constructor for the disease model, remember we're passing through the mean immunisation duration and the probability of being immunised right from the user interface, because the user is going to be able to specify that. So it's going to need to pass in first into the disease model, and then that will then be passed in turn to the agent. So in the constructor for the disease model, we need to add mean immunisation duration and probability being immunised, because those things need to be passed in. They'll be passed in from the user interface, and then in turn, when the disease model constructor then starts setting up agents in this loop, then we also need to also give it the mean immunisation duration and probability being immunised that we've passed through, because remember up here we added those things into the constructor for the agent. So that's everything set up. We don't need to change anything else in the model. We've set up the extra stuff that we need. We've got the extra stuff for the data collector, and also the concept of becoming immunised and calculating how long they'll remain immunised and not infecting immunised people, etc. The run file is going to remain as it was before. Nothing changes there. It's just launching a server. But in the server file, remember, we want, now that we're collecting the total number immunised over time, we also want to graph those, and we also want to represent our agents on our grid in a slightly different way if they are immunised. So if we start with that, so in our agent portrayal, which remember is the bit that agent portrayal function which defines the way in which agents are portrayed on our grid. Before we just checked to see whether they were infected or not, and coloured them red if they were and grey if they weren't, and changed the size. What I've added here is an elif statement to say, okay, they may not be infected, but let's check if they are immunised, if the agent's immunised. If they are immunised, then I want them, I've chosen to have them coloured blue. I want them on the same layer as if they aren't immunised or infected, and the same size as if they aren't immunised or infected, so a layer of 1 and a portrayal radius of 0.2. So what we should then have is large red circles representing infected agents, small grey circles representing non-infected and non-immunised agents, and small blue circles representing agents who are not infected and are immunised. So that's everything we need to change in the agent portrayal. we're going to need to, on our graph, we said we wanted to add the total number immunised over time to our graph. So in our, I've changed the name slightly because we had this called the total infected graph. That's a bit misleading now. So I've changed the name of this to total infected and immunised graph. And then I've added in an extra dictionary here, which specifies that for label total immunity, which is the thing that's going to be collected in our calculate total immunity function, and I want that line coloured black. So it'll plot that value, total immunity, which is being collected in the data collector. I want that coloured black, but on the same graph. So that will set up our graph. The last thing we need to do is then just to add in our 2 extra sliders. So we've got probability of being immunised and the mean immunisation duration. And we've got these extra sliders listed here. So you can see on the probability of being immunised, I've got the default probability of 5%, which is what we said we wanted. A minimum of 0, so I'm going to allow 0. I'm going to allow that that nobody will be immunised, which is sort of talking back to how it was in the original version of the model. Up to 100% of people can be immunised, or sorry, 100% probability that each agent will be immunised on each turn, and I want that in increments of 1%. And for the mean immunisation duration, we've got a default of 20 days. I've set a minimum of 1 day because it doesn't make sense to have a 0-day minimum. And up to a 100-day immunisation I've selected here. So that's our new 2 sliders. So we just need to add those things then into our modular server. We've already got the graph. But if you have changed the name of the graph, as I did, we need to change the name down here as well. And then just add in our extra sliders, probability of being immunised and mean immunisation duration. And again, prob being immunised. Here in inverted commas, that means that's the name of the variable that's then going to be passed into the model that's going to represent the value. So whatever value is selected by the user, that will get passed in as the probability of being immunised, and same with the mean immunisation duration here. And so if I were to run this model back here, so I can see here nobody's immunised at the start, which is what I would expect, because I told it nobody would be immunised at the start. I click start. I don't know how well you'll see it on the video, but you can see some of them are blue. They're starting to get immunised. And on our graph, we can see here the black line representing the total number who are immunised over time. As we would expect, as that goes up, the total number of infected should be going down. And indeed, that's exactly what we see. So you can obviously play around with that if you haven't already. So if you didn't get that solution, or you needed to finish off anything, it's going to give you sort of 20-25 minutes now just to add in those things. So feel free to look back over this video, add in those things, and then when you're ready, jump to the next video. So see you in a bit.